So, short agenda view of what we will do today. I will just introduce myself as first. Then we will go through some examples why we go for a digital twin like TwinSim in this TwinSim project. Then I will also give a short introduction. What is a digital twin? What is the understanding of a digital twin? And then I will show you our TwinSim project in our company. So my name is Paul Kokot. I'm working since almost 4 years in the Eurogate Technical Service Department, which is a subsidiary of the Eurogate Holding. Eurogate is Europe's biggest line-independent container terminal with a container handling of about 12.3 million TEU per year. My background is electrical engineer with a focus on automation. I worked about 10 years in the offshore wind farm market, and therefore I think I have a great amount of experience in dealing with data at the area of operation and maintenance, because all these machines are offshore, so you can't get to the machine and just working on them. You need to do all this stuff due to data. So was my main focus. Currently, I'm working in the Department of Automation and Operation Technology as head of the digital applications. And at the same time, I'm the project leader of the project TwinSim. I brought today 2 examples from the past why we decide to make a digital twin. These 2 samples are not just the 2 why we did it. There are many, many others. But I want to give you some introduction how the decision is going on in the company. Yeah. So the first one is the data digging for failure cost analysis. In the past, we put many effort to analyze which failures are the expensive one. And the difficult situation was that all the data was spread over different databases and must be collected manually. So there was no tool to visualize this. So everybody thinks about how to do it, and what do you do if you don't have any tool? You use the number one digitalization tool, which is called Excel. Yeah, so you can imagine how many work is needed to bring these data together. And again, every day we have make an analysis or make a new failures to analyze them. We have to do it again and again. And the result of this analysis was always questionable. Yeah, because it was done manually, so there was some failures in it. So data was not fully complete, and therefore we decide to do it better. And we start a POC to do it better. And the POC was that we set up a dashboard in Tableau to give the user a graphic UI to browse the data. Yeah, so that was the first step. On the right side here, you see the straddle carrier, and you see that the spreader is marked deep red. Yeah, what does it mean? It means that the cost for this component is the highest ones for the failure in this component. And now you can click on it and you can browse deeper into the subcomponents of this spreader, and you will get the costs for each component shown in this graphic UI. So that was much easier to use, and you have always the data at one point. The problem of the idea is that we didn't have a central database where we can put this information in. So the end user still have the same problem to prepare the data to use it. And that was one of the reasons why we said, okay, we need something like a central data lake. Yeah. The other example is we had breakdowns during the operation due to low tire pressure on the straddle carriers. Yeah. And there were several tries to fix this before. Yeah. And these breakdowns to fix these breakdowns, there were many difficulties. So the first thing was that the data was for the pressure of the tires was just stored on the machine itself. So there was no possibility to get it out, or it was some tool where you can visualize it. Yeah. So the technical guys has no possibility to browse to the data. And I have here some example just of such a behavior of a pressure. And you see that at the start of the machine, where here in the blue color, we was about 10 bar pressure, but immediately after start, it's rise to 2 bar more, so we was 11.7 or 11.8. And this problem was that to analyze, is this pressure okay or not? Yeah, and also here we start. And also the data was not complete, so that means we pumping up events, for example, were not included. Yeah. So also here we start a POC to make it better. Yeah. And the POC was split in 3 steps. As first, we collected data to a central database to get it from some machines, not all, but some of them. And afterward, we calculate an idle pressure, which is shown here in the first picture. Yeah. And the tire, what is the idle pressure? The idle pressure is that the tire is cool and the stride carrier was not moving of minimum of 1 hour. Yeah. And we put a threshold to this data and monitor if the threshold is raised. Yeah. And if this happens, the maintenance team was informed by an email. Yeah. This worked good, and the maintenance team was happy about it. That they are now knowing that there are some problems with the tire, but it still happens during the operation. So the problem was still there that we have an interruption, and we said, okay, then let's do it better. And we tried to put a trend line into these data, and you see this in the second point. But the problem here is that due to the low data which we had here, the prediction for was not precise enough. Yeah, so we decide, okay, we need to insert a better solution, one with more data, and we said, okay, we will not, and this is the third one, we will not go through one tire and just fix it on one tire and look on one tire, but we will look on all 8 tires together at the same time. And this is what we see here in the next picture. In the third one, where we see the 7 tires which are almost on the same level, but we see the green one which is in a different behavior. The problem here is that the data is not continuously given. So the machine is switching on and off depending on how many we use it. And so the data is not complete. And this is the marks here between. And the problem is that the method which we use, the Kalman filter, need a continuously available data with a fixed sample rate. And so the problem was here, the solution was not working properly. So at the end, we saw that we have here also the same problem. We have the data quality is not enough, and we need something to build which gives us a better view, a better data quality, and also complete data of the whole system. And that was the idea and the solution that we said, okay, let's go for a digital twin, and the project which we start was TwinSim. And as I said, this is just 2 examples, and we had many others also from other departments. But as next, I want to show you what is a digital twin. So in the literature, we talk about 3 terms. The smallest one is the digital support system. Then we have the middle one, which is called digital shadow. And the last one is the digital twin. And this is the complex one. But what are the difference? So a digital support system is something where the data is transferred manually from the real world to the digital system. And this is like Excel. Yeah, you have to put the data all manually in. Excel makes some calculation. You take the result and put it into your operation, and then something happens. Yeah, and you collect again all the data manually, put you in the digital system. So you're in your Excel, make some calculation, and again. So there's no automatically data exchange. This is called digital support system. The next one, the digital shadow, is a one-way exchange of real data. Yeah, and typically this is something like visualization. yeah, or SCADA systems, yeah. This is something like a digital shadow. So we get live data from the operation into the digital system. Some calculation is done or views or whatever, yeah, and the result is not transferred to the operation. It's something which you need again to take manually, and you do something in operation, and afterwards you can you see the maybe the result in your data. Okay, and the last point is the digital twin, and this is what we are understanding in the digital twin, is that we have a closed loop. That means we collect data, the system is making some calculations, some predictions, whatever, and the result is put automatically into the operation, and you have immediately an impact on your data again, and can see the results of it in the data itself, and the loop is closed, and this is a digital twin. So this is what we have said. Okay, the last thing, the digital twin, is this what we want to build, and we started TwinSim project. But what is the TwinSim project? The TwinSim project is a funding project, and it's planned for 3 years with a project volume about 3.6 million euro. And we have 4 partners. We have AKQUINET, Port Consulting. Thank you for being today here. And we have the University of Hamburg. We have also some people sitting here. I think Leonard is not here, but I think Julian and some others are also here. We have Eurogate IT and the Eurogate Technical Services, where I'm from. But the project is not just this 4 partners. We have many stakeholders which are interested in this digital twin. And these are mainly our Eurogate terminals, but also the technical departments and IT departments. And as I said, the project is a funding project, and it's funded by the Bundesministerium für Digitales und Verkehr. And as I said, it runs about a year already and will end 2024. So we will do the project in the container terminal Hamburg. So this is where we will build the POC, or we are doing this already. So we set up already machines and IoT devices and other things also. The idea is we will have enough data also there because of handling of 4 million TUs in a year. We will sure have enough data to collect in this digital twin and to compare. So this is the location where we do this. But how we start to build this project? Everybody asks, how can I start? And the first thing what we have done is we spent many time on collecting the requirements and use cases. So herefore we develop an own process, and thank you for the university to help us in this process. We start with some identification workshops at first, where we just brainstorm together with the stakeholders what could be required and which use cases are possible. Yeah. Many ideas comes here together. We get more than 120 ideas just for what could be done with a digital twin, yeah, and where the benefits will be. Afterwards, we spend time in small groups and discuss these ideas in detail and bring all these ideas to the same format, yeah. And after some process of criteria settings and weighting of this criteria, all these use cases was rated by the stakeholder itself. So they rate which one are the most important for them. Yeah. So at the end, we get a prioritized backlog full of use cases and requirements for digital twin, and that was the result. And that was and we are very happy about this, because now we don't just have use cases which we will do in this POC of this 3 years, but we have also use cases for long term. Yeah, where we can develop new things for the next years. Yeah. After we had all these the 25 most use cases we will do, we start with the architecture to build the architecture for digital twin, and this is what I will show on the next slide. So here's a rough architecture of what we will do. Yeah, and we see here in the bottom all the container handling equipment like straddle carriers, QCs, RTGs, And this equipment will be connected via IoT solutions to a central data lake. These IoT solutions are already available. This is nothing new. Yeah, this is something what is already on the market, and there's no need to develop new things, new strategies, how to provide data from this machine to a data lake. This is already given. You can just buy it on the market. Yeah. But what we have done is to use this IoT technologies, but with a new protocol. So we set completely on the TIC 4.0 definition, and this is what you see here. So we said all machines has to transfer their data due to the TIC 4.0 standard. And this is the very important thing, because the TIC 4.0 defines the need to bring data from, the TIC 4.0 is, the idea is to set up a data semantic, but also to define which data is important for specific equipment. Yeah. So you don't need to think about this again for your own project. This is already defined, so let's use it. Yeah, that was the idea. And TIC 4.0 defines also that not just the data from the machine is needed, but also the data from systems like the TOS, the ERP system, or external data. So you need to bring these data together. And this is why we have put also the possibility in to connect TOS. And also here we will speak TIC 4.0. There are some for sure there are needed translation modules which will translate this data into this TIC 4.0 format. But this is what we want to build in this TwinSim project. Now all this data is available in this data lake, and the idea is now to fuse it together, to bring it together and to have all the context of all the machine data, the TOS data, the weather data, for example, with the external source, or whatever you want. Yeah. Also maintenance data. These things will be brought together. And now we have a data lake with many data, but this will not give us a value. Yeah, this is just data, so we need to do something with it. And the first thing what we will do is to visualize this in 3D. And this is what we have seen already from Horst Dieter. We will use the CHESSCON live view for showing this information in a live 3D environment. In the top layer here, you see that we have some other services which will be available, but more on the next slide. So what we have done, due to the requirements and use case, we identify 6 key functionalities which our digital twin needs to fulfill. So data collection is the most important one. It means to collect data from different sources, to bring it to TIC 4.0 format, to fuse them together, to store in a database, and to provide these data to different services. The analysis function will be possible as well to analyze real-time data and also historical data, but more later to it. The visualization, which we already saw in a presentation from Horst Dieter, is needed for the live data visualization, but also for things like simulation, yeah, and also for we will have a third visualization which is called dashboards. So we will provide dashboards where we can show KPIs and historical data, and also to allow the users to dive into the data. So they will have all the data available and can see what happens in the data itself. Yeah, because they need to analyze these manually, these data, to get new applications. Yeah, for new ideas to solve by using this data. The simulation will allow us to replay the shift to get answers what has happened, and also to do simulation into the future. Is something what we had also see in the morning from Horst Dieter. And the idea is to use the simulation to give the end user a better idea of what is the best decision. For example, how many equipment is needed for a shift or whatever. Yeah. So this is the use of the simulation. The optimization means we will have a set of tools which give us the possibility to use modern solutions. So, and what are modern solutions? All of you already read the words like buzzwords like KI, AI, or just smart algorithm or whatever. Yeah, and the platform what we will have will give us the possibility to use it. So there, the data lake is open for such solutions. Yeah, and so we are open for the TIC 4 for the 4.0 world outside of our market. And the last key function is the control. And depending on the result of calculations done in, for example, in the optimization, the control is needed as for the closed loop. Yeah. So if we want to close the loop for in such a digital twin, we need the opposite direction of data flow. And we will start at the beginning with simple things like controls of the container handling equipment, but later this function can be bigger and give us also the possibility to close this loop. As I said, for the analysis and the visualization, the long-term use case for this is to move from the descriptive analytics to a prescriptive analytics. Therefore, we need to extract insights and patterns from historical data, for example, speed, time to lift, drop, energy consumption, empty distance, or other things. We need to bring these together with the TOS process data, also for and together with external data like weather services or arriving ships or whatever. Yeah. So to bring this together and to put it and use it in the result in a specific context for prescriptive analytics. And the digital twin will give us the possibility to move in the right direction. And you see here on the right side, the difficulty is rising if you want to check something in the past. This is easy because you have the data. But if you want to predict something, this is very difficult. And this is the part where we want to go. And the digital twin will give us the possibility to do this. As I said, we will have the real 3D live visualization. And this is something what we already shown. Here's just a small picture of it. I don't have a video of it at the moment, but we saw it already. And it will be possible to see the live visualization, but also to simulate backwards and forwards. And this visualization will have all informations from the central database. So we can have their process data from the cycle. So it means from the TOS data. Yeah, we will see all the container numbers, but we will also see failures and warnings from the machines itself. Yeah. So what happens here? We see the second crane has a problem at the moment. Yeah. And this is something what you can see immediately and not just hours later or minutes later. You will see it immediately. But we will also get informations like fuel level consumption, but also fuel forecast, how long the fuel will last, yeah, or maintenance status. So that means, will be the machine available again in this shift, yeah, or how long it will take to fix it, yeah. So all these data can be displayed here, and you have a better overview of what is it's going on your terminal. And the last thing is the simulation. We talk a little bit about it. So also here we would use CHESSCON product to analyze bottlenecks and improve them. And for the input of this simulation, we will use the production layout. We will use the equipment data, which will be collected in real time, and we will use them to make a better simulation, because we have the data how straddle carrier behaves during different weather conditions. We can use these data to make a better simulation, a more accurate simulation. But also strategies from the TOS system will be put as input into this simulation. So the output of this simulation will give us an overview of the equipment, productivity, of the utilization of the equipment, and possible, for example, possible service times for trucks or rail operations. And this enables the end user to make a better decision because he can simulate immediately because this whole simulation is connected to a database all the time. So the user can start a simulation immediately and don't need to prepare any data to do it. And this is the big advantage which we see with this digital twin.